Welcome back, students. In this video, we're going to cover Module 9, Topic 3. This is, we're going to call it Trigonometry Part 1.1. The reason we're doing that, Topic 2 is broken up into two parts, and Trigonometry is broken up into two parts, but it's 3 and 4. So Topic 4 is Trigonometry Part 2. So Module 9, Topic 3 will be Part 1, Trigonometry Part 1, and Part 2, Trigonometry Part 1. So if we didn't confuse you enough already, trying a little bit more. Just kidding, of course. Okay, so we're on page 4 of the Module 9 packet. Objective of this topic is you guys are going to solve problems using trigonometric ratios. I'm struggling with that all day. All right, so our bell work. This is like easy peasy. So, number 1, what kind of triangle is this? Hopefully you said right. If not, then I have failed. Okay, number 2, name the hypotenuse of triangle ABC. Well, it would be right there, BC. BC is always across from the 90-degree angle. All right, opposite side of C. C's over here. Your opposite side is AB. And the side adjacent to angle C, it's not the hypotenuse. That's going to be this guy. And that's AC. And these are important because we're going to use these in this lesson a lot, the whole time. All right, let's scooch down the page. We're going to label sides a little more. So we have 3 right triangles. It says label the opposite, adjacent, and hypotenuse based on angle A. So angle A, angle A, angle A. Hypotenuse never changes. So it's always across from there. So I'm just going to write it here. I'm just going to say HYP. And, well, I'll just hypotenuse. All right. Again, across from the 90-degree angle. So the hypotenuse should be just, you shouldn't have to think about it. Hopefully some of you guys looked at my shirt Monday. It had the hippopotamus. I'm not drawing that, but same thing. Okay, so angle A, we got the hypotenuse all the way across. Now we're going to do the hard stuff. So opposite, so if angle A is on the left here, the opposite is on the right, so this is your opposite. If it's on top, your opposite is at the bottom. And if it's on the right, then your opposite is on the left. Oh wait, opposite side. All right, now adjacent. Adjacent is the side that touches the angle but not the hypotenuse, so that's this. Touches the angle, but it's not the hypotenuse. Touches the angle, but it's not the hypotenuse. So, if you guys can get that down, this stuff here is super easy. Because we're going to use the calculator. And you just have to put the numbers in the right area. The right place. Anyway. Okay, had to fill in some notes there. Sorry for the dead time. I usually try to get that ahead of time, or have been lately. Okay, so trigonometry. In previous lessons, we've learned that the lengths of the sides of a right triangle have a certain relationship which allows us to use a trigonometric ratio. The word trigonometry, it comes from the Greek terms trigon, which means triangle, and metron, which means measure. So the study of trigonometry involves triangle measurement. A trigonometric ratio is a ratio of the lengths of 2 of the sides of the right triangle. So consider the following triangle. So we got these guys here. I'm going to go ahead and move the camera to get where I can see everybody. Okay. For angle A, find the ratio of the opposite leg to the hypotenuse. So for angle A, so opposite, so the angle A is on the right, the opposite is on the left. That's 3. And the hypotenuse is the longest side, always across from the 90-degree angle. So that's 5. All right, let's find the same ratio for angle B. Angle B. All right, opposite. B's on the top. Opposite would be the bottom. That's 12. And the hypotenuse, long side. And we know by the measures what the long side is. So even if you need glasses like I do, you can still look at the numbers and see this is the biggest length, so it's the longest side. And that goes on bottom. That's the hypotenuse, 13. Okay. Flip over page 5. Okay, top of page 5. Let's talk about SOHCAHTOA. So 3 main trigonometric ratios. Complete the statements. So over here we have these letters, SOHCAHTOA, SOHCAHTOA. So this tells us that sine is the opposite over hypotenuse. Opposite over hypotenuse is sine. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse is cosine. And tangent is opposite over adjacent. Opposite over adjacent. Okay? Now we're going to put this into practice. I'm just going to keep it like that just for now. All right, so find trigonometric ratio. Find sine for A, cosine for A, tangent for A. Sine C, cosine C, tan C. Notice we're not doing B. B is the 90-degree angle. We're not going to mess with that guy. Everything we're going to do has to do with these 2 angles and the 3 sides. The 90-degree angle, it's just there. So, sine for A. I'm going to, let's see how long this red pen will work. So we'll start with A. So sine is opposite. A's on top, so your opposite in red is 16. Your hypotenuse for either of those guys is the 20. So it also asks for the decimal. So 16 over 20 is 0.8. All right, still with A. The cosine is the adjacent, so that's the angle, that's the side touching the angle that's not the hypotenuse here, which is 12, over the hypotenuse, which is 20, and that's 0.6. All right, and finally, opposite, which was 16, over the adjacent, which is 12, and that's 1.33. I'm just going to put HYP. All right, now we're going to do the other in blue. So angle C. The sine is the opposite. So C's on the left. The opposite would be the right. And the adjacent, this is the side touching the angle, not the hypotenuse, is this one. And the hypotenuse is the same for both. But notice it's the opposite. So if you're talking this angle, adjacent's this, opposite's over here. If you're talking A, its adjacent is here, its opposite's there. So that's why it's important to know, number 1, what's the adjacent, number 2, what's the opposite, and then number 3, what angle you're talking about, so you can make sure you put the right numbers in. Okay, so see, the sine is opposite 12 over hypotenuse 20, still 0.6. Notice the sine for A, the cosine for A and the sine for C are the same because they're flip-flop. All right, so cosine is adjacent, which is 16, over hypotenuse, which is 20. Same as that, 0.8. Important to know that you can do this sort of thing too. All right, the tangent for C is going to be this guy flipped upside down because, again, those are flops. So angle C is 12 over 16. See, the other one was 16 over 12. And it's 0.75. Okay. All right, down to the bottom. Page 5 on the left. Number 1. Consider the figure below. Part A says find the sine of angle T for the figure. So, and this is T and this is T. So it's T over here and it's J over here. So it's this guy and then it's this guy. All right, so sine is opposite over hypotenuse. So opposite of T is the left side is 27. Hypotenuse is 45. They only want the ratio. That's what we're giving it. And if you put it in the and you can use this to find the angle. We'll do that. We'll learn that later. Let's not get ahead of ourselves. All right, cosine for T. Cosine is going to be the adjacent, which is, again, the angle, the side touching the angle, not the hypotenuse. So, hold on, adjacent over hypotenuse. And tangent is the opposite over adjacent. Again, SOHCAHTOA. All right, so cosine is the side touching, 36, over hypotenuse, 45. And then your opposite, still 27, over the adjacent being the tangent, so that's 36. Almost. And there we go. All right, now I'm doing the same for J. So again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so for J, opposite, so it's on top, opposite's 4. Hypotenuse is 5. Go a little faster here. Adjacent, side that touches it, that's 3 over here. Hypotenuse is still 5. And then opposite over adjacent, 4 over 3. All right. Let's see, we got page 6 and 7, and that is it. Okay. Top of page 6, solve for the missing side. So missing side over here is x. I know, math teachers always looking for their x. All right, step 1, highlight the angle theta. All right, so the angle theta, and we haven't talked about this before except during this lesson. We talked about it today in class for the ones of you that were here. But the angle theta is going to be the angle we're talking about. Now here we have a measurement. So we don't have a measurement here. So we would be, this is our angle theta. And that's all that means. Angle theta means the angle we're talking about for this. So for angle theta, they want us to label the sides, adjacent, opposite, and hypotenuse. So theta is at the top. So down here is the opposite. This is the hypotenuse. It's across from the 90-degree angle. And the side touching the angle theta, not the hypotenuse, is this guy. It is the adjacent. All right, so we labeled the sides. Step 3, determine the trigonometric ratio. All right, so sine for theta, sine theta is going to equal opposite, which is 25, over hypotenuse, which is x. The cosine for theta is going to be equal to the adjacent, which we don't have a measurement, so we're just going to put AJT over x. And the tangent for theta is opposite, which is 25, over the adjacent, which doesn't have a measure, so we're just calling it adjacent. If we called it, I would call it x, but that's already called x. All right, so now step 4, use your calculator to solve. So we need to find x. We know this angle, so we can use the calculator and the one of the functions, sine, cosine, or tangent, to give us this length. So let's see, this is the hypotenuse, this is the opposite. We don't have a measurement here, so we're going to have to use sine because we have an opposite and we're looking for a hypotenuse. So sine, not for theta, but for 30, is opposite over hypotenuse. So we got to get x by itself so we can solve. So now we multiply both sides by x. These cancel out. You end up with x times sine 30 equals 25. Now we're going to divide both sides by sine 30 to get x by itself. These cancel. I'm going to bring it over here. So x is going to equal 25 divided by sine 30. Okay, so I don't have one of the classroom calculators with me, so I'm going to try to do my phone. So, well, I'm covering it up. All right, so x equals 25 divided by sine 30. It's going to work the same on the other calculator, but so you take 25 divided by, now I believe these calculators are the same. The one at school, you have to hit the angle measure, which is 30, sine. On the calculator at school, it's going to give you the ratio, and then you have to hit enter, but we have to hit enter with this one anyway. So 30 sine enter, so x equals 50. Okay. Hopefully I didn't lose anybody there. All right, scooch down the page. We've got 3 on the left, 4 on the right. I'm going to keep my phone handies. Let's see. Because we're going to need it for, for these. All right, so number 3 on the left. Consider the following figure. So we've got a right triangle again. And we have one angle with the measure, one without. Remember, we're not talking about the 90. He's always there. So which trigonometric function should you use to find the value of x? X is over here, so this is our hypotenuse. So x is on this side that's touching this angle. So that would be the adjacent. This, of course, like I said, is the hypotenuse. So adjacent over hypotenuse is cosine. So if we say cosine 18, it's going to equal x, that's this adjacent side, over 25, the hypotenuse. Which function would you use? You use cosine, but I've set us up. It's asking for the equation below, and there it is. Cosine 18 equals x divided by 25, and we're going to have to isolate x to solve. But let me go ahead over here, and we'll do both of those together at the bottom. I can scoot the page down. But number 4, consider the following figure. Again, 90-degree angle. Right triangle. This one has 34, nothing here, so we're using this guy. This is the adjacent side because this is the hypotenuse. Always across from the 90-degree angle. So this side's the adjacent. So we're dealing with cosine again, adjacent over hypotenuse. So cosine for 34 this time equals adjacent, which is x, over hypotenuse, which is 17. So the cosine is the function it's looking for. And then cosine 34, the equation is x over 17. Now, I'm going to scooch down since we have this, and I can put the phone with the calculator to the side once we get our equation, our x isolated. All right, so we're going to multiply. This one's really simple because to get rid of this fraction, I'm going to multiply both sides by 25. They cancel here, so x is going to equal 25 times cosine 18. So 25 times 18 cosine, you see it puts it in there, and then we hit equals. So 23.77, we're going to round that up to 23.8. Okay, just going to move it over here. Because over here, we're going to multiply both sides by 17. They cancel here. X is going to equal 17 times cosine 34. So 17 times 34 cosine. So we got 14.09. That rounds to 14.1. Okay, see. All right. Flip over here. Last page. Page 7. Make sure we got the rest of that. Sorry, I got a phone call, as y'all saw. All right. Number 7. I'm sorry, page 7, number 5. Jesus. That's what happens when I get interrupted. All right, number 5. And again, we have 2 of these. I'm going to scooch it up. We're going to set the equation up, and then I'm going to scoot it over and do what I did before. So, number 5, consider the following. What trigonometric function would you use to find the value of y? Y is over here. X is over there for this one. So we have this angle because it has the measurement that we can use to find a side. Notice y is on the hypotenuse. X is not over here. All right, so the opposite, so 62 is on the left, 18 is on the right. So it's opposite over hypotenuse, so that's going to be sine. So sine 62 is going to equal 18 over, or opposite over hypotenuse, or 18 over y. Set up an equation, well, it's the same thing. So we do over here, how do we find x? So we have the measurement here. That's the adjacent side going into the angle that's not the hypotenuse. Hypotenuse is over here, it's blank. So we're going to have to use tangent. We have an opposite and we have an adjacent. So tangent for 38-degree angle is going to equal the opposite over the adjacent. And that's going to be this equation they want down here. So we scooch down here. We're going to isolate y and isolate x and use the calculator and solve them both. So on the left, multiply both sides by y. Cancels here. So you end up with y times sine 62 equals 18. Well, divide both sides by sine 62. Cancel here. So y equals 18 divided by sine of a 62-degree angle. Just do the same over here. Multiply both sides by x. These cancel. X times tangent 38 is going to equal 19. Divide both sides. See, we did the same exact steps, and it's just practice. So these cancel. So now we have x equals 19 divided by tangent 38. Okay, let's go back to our handy dandy calculator. Maybe no phone calls this time. So y equals 18 divided by 62 sine equals 20.38. We're going to round it. So y equals 20.4. All right, for the other side, x equals 19 divided by tangent 38. So 38, tan equals 24.31. And we're just going to say 24.3. We will. Okay. Let's scooch down. We have these 2 guys at the bottom. Well, 3. 2 and then the 1 here. So, number 7. Find the values of y and z rounding to the nearest tenth. They didn't give us a lot of room, so hopefully we don't need a lot. There's your y, there's your z. We have a 7 here, and then over on the number 8, they want q and p rounding to the nearest. Okay, so two different ways we can solve this. This is a 30, 60, 90 triangle. Both of these are. If you watched the last video, we know that these are special right triangles. Well, I'm going to show you how to solve it both ways real quick. First way we're going to use, so if we're looking here, so Z is our hypotenuse. Actually, let's start here. So the opposite for this 30-degree angle, the opposite is 7, and the hypotenuse is Z, and that would be sine. All right, so we're going to multiply Z by both sides. So we got Z times sine 30 equals 7. Divide sine 30 by both sides. So we're over here with Z equals 7 divided by sine 30. Okay. 7 divided by 30 sine. Wait a minute. Is that right? Hold on. Something doesn't seem right with that. That page is... No. What did I do wrong here? Yeah, Z equals... hold on. Oh. Yeah. And you guys probably saw it. I wasn't even looking. I had it, I think I had the square root or something. Yeah, so 7 divided by sine 30 is 14. All I knew was it wasn't the right number. All right, so 14. All right, now y. So now that we have this, we can use either one. But to find y, and I like to put this on the top of the fraction so that we don't have to do all this mess. So to put it on top, it would be opposite of 60 over hypotenuse. So that would be sine 60 equals, I should have done this in a different color. Let me just do this so we separate everybody. Whoop. Sine 60 is going to equal y over 14. We multiply both sides by 14. Y equals, let's see, is that right? Oh yeah, I did it different before, sorry. Yeah, so it's going to be 14 times sine 60. So, oops, 14 times 60 sine equals, so 12.12 or 12.1, we're going to round down. All right. So Z was 14, Y was 12.1. Now, real quick before I go over here, I'm going to show you, so our 30, 60, 90, and we'll do this in red. We learned in the previous module that this side that has the 90 and the 60, the short side is x. This side over here is x times the square root of 3, and this side, the hypotenuse, is 2x. So using this, so if x is 7, 7 times the square root of 3, let me just show you, so 7 times 3 square root equals 12.12. There you go. And then if this is x and the hypotenuse is 2x, 7 times 2 is 14. So see, the math works both ways. I wanted you guys to see that. So, with that being said, well, I'll do it like it's supposed to be done. So, but again, actually I'm going to solve it this way first over here. All right, so if this guy is 12, our hypotenuse, or P, is going to be 2 times 12, which is 24. And then Q is going to be this side times the square root of 3, or 12 times the square root of 3. which is 20.78. We'll say 20.8. Okay. Now let's do it the other way. So if we're looking for Q over here, we would go, actually I want it on top because, so sine, no, not sine, it's adjacent over, opposite over, crap, it's still going to be that way. Actually, so for here, opposite over adjacent. So opposite over adjacent is tangent 60. It's going to be 12 over Q. Did I do that? No. Q over 12. Opposite over adjacent. Okay, multiply both sides by 12. Sorry for the terrible writing. Then Q equals 12 times tangent 60. 12 times 60 tan equals 20.78, which is 20.8. And then over here, the hypotenuse, so we would say for that, for P, it would be, we could just say, that's going to be on the bottom either way. It would be, opposite over hypotenuse. So it'd be tan 30, cosine 30 equals 12 over P. You end up with P is going to equal, oh, wait a minute. Hold on. That's it's opposite over that. That was sine. Okay. Yeah, it'd be 12 divided by 30 sine. Nope. Yeah, 12, not something, whatever I just wrote. Yeah, 12 divided by 30 sine equals 24, which is what we got. Sorry again for the dead air. Okay, bottom of the page, number 7. Electrician leans an extension ladder against an outside wall of a house that reaches a 26-foot electric box 26 feet up. The ladder makes an angle of 64 degrees with the ground. Find the length of the ladder. So the house and the ground make a 90-degree angle, just like when you stand on the ground. So they say 26 feet up to this box. Here's his ladder. His ladder is going to be the hypotenuse. And they say this is 64. That's important because we need to use trigonometry to find this length. So our angle is 64. We don't know if we're using, so it's on the left. The house is on, or the outside wall is on the right. That's 26, so that's opposite over, we're looking for the hypotenuse. We're going to call it X. That's the ladder. That's opposite over hypotenuse is sine. Okay, so we're going to find X, so we're going to multiply both sides by X. These cancel. X times sine 64 equals 26. Divide both sides by sine 64. So you end up with X equals 26 divided by sine 64. All right, so 26 divided by 64 sine, 26, not 23. 26 divided by 64 sine. So 28.9, we're rounding that to 29. So it's a 29-foot ladder, which is a lie. I don't think there is one. 28 and 32 foot. Anyway, that's it for this video. If you have any questions, let me know in class. Have a great night, and we'll see you next time.